Hi, I am Tapan Chakraborty. Welcome to my channel Fly with Tapan. Aircraft is made of thousands of components. Today we will see some of the major components, their location and their function. Let us get familiar first with the name of the components and their location. This is the vertical fin or stabilizer. At the rear of the vertical stabilizer, there is one control surface known as rudder. Similarly, this is the horizontal fin or stabilizer. At the trailing edge of horizontal stabilizer, there is another control surface known as elevator. At the trailing edge of the wing towards the tip, there is one more control surface known as aileron. These three control surfaces, that is the rudder, the elevator and the aileron, are known as primary control surfaces, as they turn the aircraft about one of its axis and decide the aircraft's course or direction. These two are flaps, situated at the trailing edge of the wing, towards the inner side. On the leading edge of the wing, slats are situated. And on the top of the wing, this is the spoiler. The flap, the slat, and the spoiler are secondary control surfaces. Secondary control surfaces are those which enhance some performance of the aircraft when they are engaged. If you remove the wing and the vertical and horizontal stabilizer, the remaining portion is called fuselage. Fuselage is one of the main structure of the aircraft. In the nose fuselage, it accommodates cockpit or the cabin. Underneath the fuselage or the wing, there are landing gears. The front one is known as nose landing gear and the rears are known as main landing gear. Next comes the engine. The engine is generally mounted under the wing by means of an engine pylon. Some of the aircraft engine can be mounted on the fuselage. Now we will see how these components actually work. First we will see the three primary control surfaces. The control surfaces, those movements decide the flight path or the course of the aircraft, are called primary control surfaces. We will take aileron and rudder, these two control surfaces, together for discussion. Why is it so? Because these two control surfaces are generally used together and they turn the aircraft in air. The rudder is operated by pilot by means of rudder pedal and aileron is operated by the control stick. Now let us consider the aircraft has to take a left turn. To do so, pilot will push the left rudder pedal. With this input, the hydraulic system of aircraft deflect the aircraft's rudder towards the left. Now the high airstream will deflect to the left. As a result of the opposite reaction, the aircraft tail will be pushed towards right, and the whole aircraft will take a turn about its vertical axis like this. Aircraft's movement about its vertical axis is known as yaw. But to take a turn, the aircraft has to bank or tilt also. Here comes the aileron. Two aileron move by means of hydraulic pressure, but they move in opposite direction to each other. When pilot wants to make a left turn, along with the rudder pedal, he will push the control stick in the cockpit towards left, which will deflect the aileron in this manner. Now for a turn, what should be the deflection angle of rudder and what should be the corresponding deflection angle of aileron is decided by the fly-by-wire computer. Now the high airstream will be diverted in this manner, and as a result of opposite reaction, it will push the aileron in the opposite direction in this way. So the aircraft will rotate about its longitudinal axis. Combination of these two movements make the aircraft to take a left turn. It takes a lot of time and effort to make this type of video. Your subscription to my channel will encourage me to do many more. The third primary control surface is the elevator. When pilot pulls the control stick towards him, the hydraulic system of aircraft will move the elevator in this way. The high-speed airstream will push the tail of the aircraft downward. This will make the whole aircraft to move about its lateral axis and the nose of the aircraft will go up. The movement about its lateral axis is known as pitch. So the nose up-down movement or the pitch is done by the elevator. Next comes the flap. The purpose of the flap is to produce some extra lift during takeoff and landing. It can be deflected downward. It can be set at different angle by pilot by means of a flap lever in the cockpit. Depending upon at what angle it is set, the lift and drag value will be changed. During takeoff, it is generally set to an angle of 20 to 30 degree, vary from aircraft to aircraft. In this situation, it produces maximum lift and induce small drag. But during landing, the pilot bring it to a much stiffer angle, around 60 degree. In this situation, it produces maximum drag and less lift. In some of the previous video, I have explained all control surfaces. I have given the link in the description. You can go through it. Next comes the slats. Like flap, it also generates some extra lift. The slats and the flaps generally work together while takeoff and landing. This is the cross section of the wing along with the flap and slats. When engaged by the pilot during takeoff, it becomes like this. This increases the camber of the wing and changes the aerofoil shape and produce extra lift. When aircraft reach a higher speed, then these devices are no longer required. At high speed, the wing lift is sufficient to support the aircraft weight. Then the pilot brings back the flap and slat to their initial position. Now the spoiler. These control surfaces are the braking device, engaged by the pilot immediately after touchdown. It comes up from the top of the surface of the wing. High-speed airstream strike these surfaces and creates drag and oppose the forward movement of the aircraft. There is one more advantage of spoiler. The opposite reaction of the diverted airstream pushes the aircraft downward, thereby more load on tires and create effective braking. The engine. The engine sucks the air through the air intake, compress it by means of series of compressor blade, mix it with fuel, then burn it and produce a huge volume of gas and throw it towards the rear in the form of a jet through the exhaust. Due to the opposite reaction, the aircraft moves forward. This is the primary job of any aircraft engine. But engine performs so many secondary jobs also. During landing roll, along with the wheel brakes, the engine also contributes to brake by means of thrust reverser. Thrust reverser is the arrangement to divert the thrust towards the front instead of towards the rear. So it will oppose the forward movement of the aircraft and thereby applies brake. Some of the thrust reverser arrangement are here. The electric generator of aircraft is rotated by engine. The generator axle remain connected through the gearbox of the engine. Similarly, the hydraulic motor also rotates by engine. Hydraulic pressure which operates all the control surfaces and many other useful applications. Now imagine if the engine fails in a single engine aircraft. Besides having engine failure, there will be total electrical failure, hydraulic failure and cabin pressurization failure. Real nightmare for pilots and all passengers. But if it is a double engine aircraft, then it is much more safer as there will be parallel two or more systems and event of one engine failure, pilot can utilize the other and can make the safe landing. Lastly, the landing gear. It is a very complex piece of equipment that performs so many operations. While bearing the load of the aircraft, it provides landing and takeoff roll. It absorbs the impact during landing and taxiing and provides cushion to cabin and airframe structure. The main landing gear, left side and right side having the braking mechanism, whereas in nose wheel there is no braking system. Brake system also I have already explained in one of my previous video. You can go through it. The two main wheel have an anti-skid mechanism. The anti-skid ensures while applying the brake, the tire of the aircraft should not skid or drag over the runway, rather it should roll. This is the most effective way to apply a brake. It provides the best directional control to keep the aircraft in the center line of the runway and prevent the uneven wear and tear of the tire and enhance its life. For anti-skid system, there is a sensor in the wheel to measure the RPM. Then it is compared with the aircraft speed. If the wheel is jammed or RPM is not corresponding to aircraft speed, then it will release the brake pressure and free the wheel and apply the brake again. Nose landing gear has the turning mechanism in most of the aircraft. By turning the nose wheel with the help of hydraulic actuator, it makes the whole aircraft to turn while taxiing. In some type of aircraft, turning is done by applying differential brake on the main landing gear. Suppose the aircraft has to turn to left, the pilot will apply brake only on left landing gear. It will make the aircraft to turn towards left. Stud is the shock absorber of the landing gear. When the aircraft is in the air, the stud remains in extended position. When aircraft lands on the runway, due to the weight of the aircraft, it gets compressed and press the micro switch. It sends a signal to the aircraft system whether the aircraft is in air or in ground. When an aircraft is in ground, there are so many systems which require only during flying will be switched off. Similarly, when it is in air, system which require only on ground will be switched off. Lastly, it has a retraction and extension mechanism. If landing gear are not retracted, then what is the problem? The landing gears cannot be made in aerofoil shape like all other exposed components of aircraft. Hence, it will produce an enormous amount of drag throughout the flight. So there will be more fuel consumption, more journey time, and efficiency of the flight will go down to a large extent. If you feel the information I shared with you is valuable and interesting, then please consider subscribing to my channel.